Hey there, class. Mr. Prusky here. Hope you're having a good day so far. Should be the last section of chapter 9, which is all about kind of parabolas, graphing parabolas, solving for parabolas. And so this is kind of a combination of two different types of ideas here, okay? So we're going to be graphing. So if we have a graph here, we have a parabola, right? We're going to be doing like the table where we graph stuff. We're also going to be doing, if you recall, we're also going to do like if we had graphs. Remember we had like a dashed line like this and we shaded above or below, right? We're going to be doing both. We're basically combining graphing parabolas and shading above or below the line, okay? So it's kind of a combination. So it's not really like a new idea. It's just kind of a combination of previous ideas. And these are called quadratic inequalities, right? So these are inequalities, less than, greater than stuff. And this is a quadratic function, which is a parabola, okay? No warm-up today, so let's kind of review some stuff here, all right? So to graph a parabola, we do... Oh. All right, sorry about that. We had an announcement. If we remember, for graphing parabolas, we create a table, all right? And the first thing we do is we find the x-coordinate of the vertex, okay? The formula is right here. I'm going to use a different color so we can see it better. Is x equals the opposite of b over 2a or negative b over 2a. I like to say the opposite of b because if b is negative, it becomes positive, okay? So we find the x-coordinate, and once you find that, you plug that into the equation to find the y value, okay? And then this becomes kind of the center of the table, all right? So for example, if it's like the vertex is negative 1, 4, then the numbers you're going to put in your table, you're going to have negative 1 here, right? You're going to have numbers to the left and right of negative 1. So you want like negative 2 and negative 3, and then 0 and 1, right? Something like that. And the reason why it's important to get the correct spacing of the numbers is that if this is the vertex, these y values and these y values are going to be the same, okay? So it's kind of important to get the right things. Some people on tests and stuff, they'll pick the wrong values to plug into the parabola equation, which is not wrong. It's just going to give you a different part of the parabola that's really far up or down the graph, okay? All right, and then you just kind of connect the graph. Then we have to kind of review what we did with graphing inequalities, right? So we had a solid line. Was it equal to or not equal to? Solid line was equal to, right? Less than or equal to, greater than or equal to, and a dashed line was not equal to. If it's less than or equal to, are we going to shade above or below? We're going to shade below. Sorry, my notes are not here. We're going to shade below the line, okay? All right? And that means, in contrast, if it's greater than or equal to, we're going to shade above. Now, it's kind of hard to tell sometimes with these graphs where above and below is. And what I would tell you to do here is look at the vertex for above and below. Okay, that's going to be kind of the easiest way. Basically, you draw a line straight up or straight down to kind of see where you're going to shade. And sometimes you're going to be inside the bowl of the parabola, right? So, for example, if you have a parabola like this, right, this could be above. But also, if you have a downwards parabola, this could be above, outside the bowl, okay? So you want to think about kind of what's happening here, all right? So let's get into a couple examples, and let's do this. Here we go. So, what color should we use? Let's go back to red. Okay, so we need to graph the inequality. So I think a good thing to do first, well, let's see here. Yeah, let's just go ahead and do our thing we did a while ago. So y is less than or equal to x squared minus 4. Is this solid or dashed? It's solid. And is it above or below if it's less than? It's below. Okay? Now, we need to figure out our a, b, and c for this, right? For parabolas or just quadratics in general. It's a really good idea. So what's our a? Why don't you see if you can pause the video to figure this out? All right, this one's kind of weird because it's x squared minus 4. There's actually no x value. There's just an x squared and a c value. So for this one, a is going to be 1, b is going to be 0, and c is going to be negative 4. Because another way you could write this is y equals x squared plus 0x minus 4, right? So if you're not sure what it is, kind of fill in what's missing, okay? All right, so now we're going to do our vertex equation. So it's x equals the opposite of b over 2a. So b is what? B is 0, so we have the opposite of 0 over 2 times what's our a value? 1, okay? Opposite of 0 is 0. 2 times 1 is 2. That's going to equal 0. So the vertex goes right here, right? So 0 is going to be the x-coordinate of the vertex. How do we find the y value again? Well, we're going to plug 0 into this original equation. We're going to plug 0 into x squared minus 4, okay? So let's go ahead and do this. So let's go ahead and, so we have, so we're plugging into x squared minus 4, so we're going to do 0 squared minus 4. What is 0 squared going to be? 0 squared is going to be 0 minus 4 is going to be negative 4, okay? And then what numbers are to the left and right of the vertex? Well, we got negative 1 and negative 2. You can make a number line if that helps, right? You can do a number line here, 0, negative 1, negative 2, 1 and 2 is the other side, right? That helps you visualize it, okay? And now, we're going to plug in 1 and 2, or negative 1 and negative 2 in here into the original equation to find the other coordinates. Which ones do you think would be easiest to plug in, 1 and 2 or negative 1 and negative 2? I'd say 1 and 2 because they're both positive. So we got 1 squared minus 4, okay? What is 1 squared going to be? It's going to be 1. What's 1 minus 4? Negative 3, so we get negative 3. Which value is also going to be negative 3 up here? It's going to be negative 1. Remember, there's kind of a mirror image here, okay? These are going to be also, this one's going to be, we don't even need to do any math for this. We know it's going to be negative 3, okay? How about 2? We have 2 squared minus 4. And what's 2 squared? It's 4. What's 4 minus 4? It's 0. And we can plug in if we want to. We can also see this is also going to be 0 because it's going to be a mirror image. Okay? All right, sounds good. So let's go ahead and graph this. Let's graph the points first. We know it's going to be a solid line from our work over here before, so that's good. A little bit easier to graph. So 0, negative 4 is the vertex. So we start 0, go down 4. We have 1, negative 3, right 1, down 3. We have negative 1, negative 3, left 1, down 3. 2, 0 right here, and negative 2, 0 right here. It's going to be a solid line. Okay, so we go like this. And so there's our parabola. Now we're shading below, okay? So we look at the vertex here like we talked about before. Here's the vertex. If we draw a line, an arrow straight below, is that area in the bowl of the parabola or outside the bowl of the parabola? It's outside the bowl of the parabola, right? So this is where we're going to shade. So for this inequality, any point in that shaded section, not in the bowl, the line would actually be included, but anywhere in that shaded section is going to be a solution to that inequality, okay? And that's kind of how it works, all right? So why don't you guys go ahead and try 2 and 3. They're down here, the next page. And I'll leave it zoomed out here so you can see what the steps were. And then we'll kind of go through them together. All right, sounds good. Number 2, let's see here. Let's use a different color. All right, first things first. We have y is greater than negative x squared plus 6x minus 7. Is this solid or dashed? It's dashed. It's not equal to. And is it above or below? Above. Okay, it's above because it's greater than. Okay, so we know that. What's our a, b, and c here? We need our a, b, and c. A is going to be negative 1, sorry. B is going to be 6. I got to fix that negative 1. It's kind of whatever. This is negative 1. Okay. And C is what? Negative 7. Okay. What's the next step? Well, we got to find the vertex, right? So it's opposite of B over 2A. That's the x-coordinate of the vertex. So what's the opposite of 6? We got negative 6 over 2 times what's A? Negative 1. So we have negative 6 over negative 2. And what's negative 6 divided by negative 2? Negative 3. So negative 3 is going to be the x-coordinate of the vertex. All right. Now, this is where it gets a little tricky here with these negatives floating inside of the x squared. If your graph didn't turn out so good, just kind of pay attention here, okay? So what we're going to do is we're going to plug negative 3 into this equation, or inequality. But we're going to do, we have to be careful, okay? So we're going to have negative parentheses negative 3 squared, okay? Because, something's weird here. Oh, it should be positive 3. I goofed up. I'm sorry. I got to fix that. So you may not be able to see everything here. I'm erasing, but so negative 6 divided by negative 2 equals positive 3. I apologize. So, but here's what we're going to do. We're going to do negative parentheses 3 squared plus 6 times 3 minus 7. Okay, so this original thing here, we have the negative parentheses 3 squared. That's where people make a lot of mistakes, okay? I would put parentheses around the 3. And so what do we do first? We do the exponent or the negative first? We do the exponent. So 3 squared is going to be 9. So we have negative 9 plus 18 minus 7. okay? And that's going to equal, negative 9 plus 18 is 9. 9 minus 7 is going to equal 2. So this is the vertex is 3, 2. All right? Now, we need numbers to the left and right of 3. To the left of 3 on a number line is going to be 2 and 1. How about to the right of 3? We have 4 and 5. Okay? You can plug in any side that you want. I'm going to plug in 2, though. I think 2 is a little bit easier. So we have negative parentheses, 2 squared, plus 6 times 2, minus 7. And up here, we're going to do negative parentheses 1 squared plus 6 times 1 minus 7. Why don't you guys see if you can simplify these? Feel free to use a calculator or try to do the math. Be a good thing to do, too. All right, so for this one, for 2, we would have negative 4 plus 12 minus 7. That's going to be 8 minus 7, which equals 1. Which one's also going to be 1? 4 is going to be 1, okay? How about 1? 1 squared with a negative is negative 1 plus 6 minus 7. So that's going to be 5 minus 7 is negative 2. And also this one's going to be negative 2. Okay? So now we have our points here. So we have 3, 2, go right 3, up 2. That's the vertex. 2, 1, go right 2, up 1. Another thing I forgot to mention, I guess we don't really need to talk about it. It'll kind of make it itself. But is this open up or open down? This is open down because we have a negative 1 for the a value, okay? There's something else to review here. All right, then we have 4, 2. So we go, 4, 1. We go right 4, up 1. We have 1, negative 2, right 1, down 2. We have right 5, down 2. Okay. It's a dashed line like we talked about. Okay, it's a dashed line, so we're not going to do a full solid line here. All right, so there's a dashed parabola. And we're shading above. So we draw a line. So where's the vertex? Here's the vertex. Draw a line straight up. Are we going to shade inside the bowl or outside the bowl? Outside the bowl. Even though it's, kind of open down, above that is going to be outside the bowl there. Okay? All right, last one. Number 3. So we have y is greater than or equal to x squared plus 3. Is this solid or dashed? Solid. Is it above or below? Above. Okay. All right, so we have a equals, we got to find our a, b, and c. Okay. A equals 1. What's our b? 0. Remember, there's no b x value here. And what's our c? 3. So we're doing negative b over 2a. So what's the opposite of b? Negative 0, opposite of 0. Over 2 times a is 1. Is 0 over 2, which equals what? That's going to equal 0. So our vertex x-coordinate is going to be 0. Okay. Then we're going to plug in, I guess we can find numbers to the left and right of 0. What numbers are to the left of 0? Negative 1 and negative 2. How about to the right of 0? 1 and 2. Okay. So we got to plug these values into the original equation now. So we have x squared is going to be 0 squared plus 3. What is 0 squared going to be? 0. And what's 0 plus 3? It's going to be 3. Okay. Should we do negative 1 and negative 2 or 1 and 2? I think 1 and 2 are easier, so I'm going to do 1 squared plus 3 and 2 squared plus 3. What's 1 squared going to be? 1. What's 1 plus 3? 4. How about 2 squared? 2 squared is going to be 4. What's 4 plus 3? It's going to be 7. This might be a little bit off the graph, too. I apologize for not mentioning that. Which ones are going to match up here, too? So 1's going to be what? Our negative 1's also going to be 4. And negative 2 is going to be 7. Okay? All right, sounds good. So we had 0, 3, go up 3, put a point. There's our vertex. 1, 4, right 1, up 4. This might be a little bit off the graph. So negative 1, 4, left 1, up 4. Right 2, up 7, 1, 2, 3, 4, 5. The top of the graph is 6, so we kind of go up here. And then we have left 2, up 7, kind of like this. It was a solid line, okay? Solid line. And we're shading above or below? We're shading above, so circle the vertex straight up. Is it in the bowl or outside the bowl? In the bowl. So we're going to shade like this, and that's going to be, our solution is the shaded section there. And the line. Solid means it's part of the solution. Okay, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.